Good afternoon. We present to your attention a report on the tropic photovoltaic technologies, problems, technical and economic losses, prospects. Anastasia Sverdlova reports, in Ukraine there is a law on the electricity market in terms of penalizing electricity producers at the green rate for daily generation imbalances in the network relative to the accepted and agreed with a guaranteed buyer forecast from the manufacturer. Responsibility for the accuracy of forecasting rests with the producer, in order to limit the impact of support for electricity producers on the green tariff on electricity prices. Producers of green energy are fined for deviating from the approved forecast, by 10% for SPP. For large producers with a share of 5% or more in the total energy balance of the country, respectively, the tolerance will be 5%. Cloudless sunny weather has a positive effect on the growth rate of energy generation. But on cloudy days, there is a high density of cloud masses, which causes a decrease in the amount of production of this type of resources. The most urgent solution to this problem is the need to forecast the amount of electricity that a particular solar station can produce. High-quality forecasting enables manufacturers and operators of grid companies to competently manage the performance indicators of solar panels, thus effectively introducing green energy into the overall energy system of the country. Pollution can easily cause electricity loss of more than 1% per day and is a specific phenomenon that depends on local climatic conditions. As a result of natural processes and human activities, dust is formed, which is present in the air in the form of solid suspended particles, PM. The properties of the dust particles vary depending on the location. Dry desert areas are characterized by electrostatically attracted inorganic materials. In coastal areas, salt and dirt caused by rain. Industrial and cooler areas are dominated by windborne organic mud, evaporated rain deposits, and atmospheric pollutants from fossil fuels. Assess the global impact and cost of pollution. The optimum between cleanup costs and pollution revenue loss between cleanup activities was identified for the top 20 photovoltaic markets. According to the data and estimates, pollution led to a reduction in global solar energy production by at least 3 to 4% in 2018, which led to a loss of income in the world of at least 3 to 5 billion euros. Based on the assumptions made, global pollution losses could rise significantly to 4 to 7% of annual electricity generation, leading to economic losses of more than 4 to 7 billion euros by 2023. Already mentioned, removing dust from photovoltaic modules is important for increasing output power. The removal may be natural, mechanical, or chemical. Natural methods of dust removal are based on wind energy, gravity, and rainwater. Transparent electrodynamic shields, also called electrodynamic dust shields, repel dust particles, creating a time-varying electric field above the surface. In general, cleaning methods can be divided into manual, semi-automatic, and fully automatic. The market for fully autonomous cleaning, which is only 0.13% of the current global solar power capacity, will grow from 1.9 gigawatts to 6.1 gigawatts in 2022. Provided can be compared with assumptions about the potential to reduce pollution and the current costs of various technologies. Automated cleaning systems, ASC, optimized photovoltaic module design, and tracking solutions are expected to achieve an acceptable utility-wide cost range. On the contrary, electrodynamic shields and heating solutions seem too expensive or technology is underdeveloped. A serious problem for photovoltaic systems worldwide, which is even more worrying due to the rapid expansion of the photovoltaic system market. Mitigation strategies should be implemented to eliminate or mitigate its effects and should be tailored to the specific conditions and configurations of each photovoltaic facility. In addition, the complexity and variability of pollution still make forecasting difficult. For these reasons, it must be constantly monitored. Pollution can also be assessed directly on the basis of photovoltaic data or environmental parameters, without the need for special pollution monitors. An economic analysis was presented to estimate the maximum allowable monitoring costs. The results show that the allowable costs of monitoring pollution vary depending on the size of the system and the effectiveness of the pollution reduction strategy. Thank you for your attention.